Okay friends, today we start the last topic of transistors as the transistors applications. Now we know that the transistors have mainly two applications. One is the amplification and another is the switching. Now transistor used as the amplifier. Now what is the meaning of amplifier? The amplifier which raises the level of weak signal. If you have a signal is very weak, then loudspeaker cannot speak properly. That's why we need it amplify the signal. It means the level can be increased, but no change in the wave shape and frequency of the input signal. Here are the block diagrams that amplifier circuit, input signal and output side is the load, maybe the loudspeaker or maybe the circuit which use the higher level of signal. DC supply is given. Now circuit arrangement of common emitter type transistor amplifier. Why we are using the common emitter amplifier? As we discussed that common emitter amplifier having a very high gain, voltage gain, power gain and the low input resistance and high output resistance. So these are the characteristics suitable for the common emitter. That's why the amplifier circuits are use common emitter type. As shown in circuit, there are NPN transistors, input side CCI and CCO. These are the coupling capacitor which are coupled with the circuitry with the input signal and output signal. Supply voltage is the input side is the VVB. It means voltage between base and emitter. Input resistors RB, the current flow is IB and IE. Output side the supply voltage is VCC with the load side resistance is RC. The voltage between collector to emitter is VC. Okay. Now we saw the working of the amplifier. Now base emitter junction is forward bias by VVB. It means input side we given a forward bias and the collector base junction is reverse bias. That's why the transistor is working on the active region. Now during the positive half cycle input signal, forward bias is increased. So base current is increased and base current is increased. That's why the collector current is also increased. If IC is also increased, that IC RC drop. It means in series resistance collector side is RC, the drop voltage drop is increase and increase, that's why the output voltage VC is decrease because VC is equal to VCC minus IC RC and these are the output is given in the reverse direction. It means positive half cycle is increased for 0 to peak side positive, the output is 0 to negative side. It's called the 180-degree phase shift as shown in the figure. So we always use, as I say earlier, that common emitter as an amplifier and its offer current gain and voltage gain very high compared to CB and CC amplifier. So these are the first application. Now second application is the transistor as a switch. Now we did transistor working in the active region. Input is forward bias and output is reverse bias. Now basic operations of the transistor is the switching devices in figure A. The transistor is a cutoff region. Cutoff it means the input and output circuit are both connected with the reverse bias. So cutoff it means 0 volt is applied. So IB is equal to 0. At that time IC is equal to 0. IC is equal to 0, that means VC is equal to VCC. That's my open switch. So here base emitter is the not the forward bias, so IB is equal to 0, IC is equal to 0 and as shown in figure they are working as a off condition of the switch. Now in the case 2 we are using the saturation stage. Now saturation stage means both are connected in the forward bias mode. So that's why here the transistors forward bias both side is given, the input is connected with the VBB supply. That's why the IB current flow. So IC is current flow as a saturation side. Forward bias IB is larger. So value of the collector current also high. And in this condition, the collector emitter is short as shown in the circuit. So these are the two main circuit there we can arrange the transistors working as a switch, either close or open. That's why it's called the closed circuit. Thank you.
Dear friends, today we are discuss about the field effect transistors. Now, field effect transistors is a construction is the same as the transistors, but there are some difference that we see. What is the difference mean? It's also called as a unipolar transistor. Now, unipolar, why they are called as a unipolar? Because there were electrons or holes, either or their charge carrier is involves single carriers. So single carriers are as in operations, that's why it's called the unipolar. Now we see the construction. There are three terminal: drain, source and gate. Now drain, source and gate, in between there are channel. It's called as either they are p type or n type. Now these are the symbols or constructions like that. Now here we can see that if we are using the semiconductor n-type material to n-type material between this p, it means that p is a sandwich in between these two. It's called as p-type. Same way here, when n-type material is a sandwich between these two p-type semiconductor material, so it's become n-channel. Now charge carrier is flow from drain to source, and then this controlled by the voltage between this gate to source. Now we can see the types of FET. Majorly types of FETs are there two types. One is the junction field effect transistors and another one is the metal oxide semiconductor FET. So further they are departed is the depletion mode, here depletion mode as well as enhancement mode. Now in depletion mode, same way, if the channel is n-type, so n channel Jfet. If depletion channel is the p channel, then it's called p channel Jfet. Same way here, there are two category: depletion mode and enhancement mode. Same way, n channel, p channel, n channel and p channel. This will be discussed in the next session. Here we are discuss about the Jfet. Now Jfet is the depletion mode, is n channel and p channel. It means p channel Jfet and n channel Jfet. Now here is the symbols: gate, drain and source. Now arrow is the inward, inside of the from the gate, and this is outside. So n channel is the inside and p channel is the outside. Now how is the working of Jfet? Now to understand the Jfet, there are two cases. First case is VGS, it means the voltage between gate and source is 0 volt, and VDS is greater than 0, it means drain to source, this voltage is greater than 0. And second case is VGS is less than 0, it means negative, and VDS is less than VDS of case 1. So we have discussed here the first case. So these are the constructions: n channel, p-type material, p-type material. So p-type material, n-type materials together make a junction, here junction and here junctions. So this creates a depletion layer here and the depletion layer here. Now the voltage VD is applied between drain and source. Source is grounded, it means 0 volt potentials. Now this positivity is increased here. That's why what happened at that time, the electrons are flow from source to drain this way. So this current is called as natural current. Like that, natural currents, electrons flow from source to drain, and conventional currents, drain current, it means drain to source. It means like this way, drain to source. So here these are the construction, and how it works we can see. Now when we increase the value of VDS, now if we increase the value of VDS, so what happen, the voltage here drain to source is the portion of channel. Now portion of channel is behave like a resistive drops. So here the voltage is more than compared to source, so more potential drop is here. So potential's value is higher at the upper side respect to bottom. That's why here the depletion layer is increased more compared to bottom side, and these two are together. As the VDS is increased, depletion layer is increased, and depletion layer is increased in such a that they are touched together here. It's called VP. So here is the depletion layer is increased, more voltage is the upper side, so n channel passage will be block. So ID is increased according to Ohm's law. ID is increased according to Ohm's law. So VGS is equal to 0, and value of VD is for which two depletion region touch is called the pinch off voltage. So it's called as a pinch off voltage. So VDS is equal to VP, the flow ID is stop and become constant. So here is the graph. Now value of the VDS, and this is the value of ID. At the time of VGS is 0. At starting this behave like a Ohm's law, and then after when the value is reached, voltage is a VP, then it becomes constants, and this. So this graph cut here given a 4 region. One is this region is called Ohm region, this is cutoff region, and above this is saturation region, and beyond that it's called breakdown region. So VDS greater than VP, then saturation conditions, and flow of ID stop and constant. Now if VG is negative, here VG is negative, as here we say in case 2, the VG is negative and VDS dash is less than VDS, it means the saturated value of the voltage between drain and source, which will be less with compared to VDS in case first. At the time what happened? The gate, here is the gate at the p-type material is a lower potential with respect to this channel. So here both side is a reverse bias condition, and this reverse bias condition will create more depletion layer, and that's why this same in a case 2 behave and touch here together and block flow of current. So this way, same way, these are when the VGS value is to be increase as a -1, -2, -3, they are early saturated and breakdown, early saturated and constant, early saturated and constant. So this way we can understood the FET in both the case. So how we can understood very easy way. So here is the we understood, suppose these are the, here is the tap which will be control the flow of water. So these are the gate which control the flow of water. So is equivalent to ID, it means the drain current. So drain to source, when the water is flow, and these are the pressures, or this will control the flow of ID. So same way these are implement here in the drain to source current flow, but here gate is applied and depletion layer is increased, and control the flow of ID. So these are the simple example to understood. Same way we can also understood, suppose in a pipe the flow of water, and now here we are given a pressure in the both side. So this will be compressed, and one stage it will be flow the water. So same way we can understood the FET. Okay, thank you very much. Dear students, today we are discuss about the Mosfet depletion mode Mosfet. So in previous video we discussed about the FET. Now basically FET is the two parts. One is the Jfet and another one is the Mosfet or insulated gate field effect transistors. Now as here so, Mosfet is the metal oxide semiconductor field effect transistors, basically two types. One is the depletion mode and another one is the enhancement mode. Now in depletion mode, same way in FET it says N channel and P channel, same here is the N channel and P channel, also enhancement is the N channel and P channel. So today we discuss about the depletion mode. Is basic symbols is given. What is the difference here for the symbolically in FET or in depletion type MOSFET? Here is the two line is draw, one is the gate, and this line and this line between this we are separated. So here is the insulations is provided between these two. These are the major difference between the FET and the MOSFET, and one additional terminal is the substrate. Now we see here depletion type, it's require gate source voltage. It means voltage between gate and source such like that is behave like a switch device off. It means is a normally closed switch behave like this way. In enhancement mode requires gate source voltage VGS to switch device on, and this is normally open switch. Now we here in this video we discuss about the depletion mode N channel and depletion mode P channel MOSFET is construction and working. So here N channel depletion type MOSFET, here is the construction. Now as shown in the figure, we take two N type material semiconductor material and P type semiconductor material. P type semiconductor material consider as a substrate and terminal is SS, and N type material is one is the source and one is the drain. In between these two, the closed conductive channel is available is the N type, and one is the gate terminal. Now in this, here is a very thin layer as the insulation is imparted between gate and substrate is silicon dioxide. So here as is a source, G is a gate, D is a drain, SS is a substrate. Now we want to discuss about the working of MOSFET of a depletion type. So here we considering two cases. In first case, suppose we are given a VGS is equal to 0. It means no voltage is given. It means a gate to source is a ground, substrate is also to be ground. So this terminal is a grounded with respect to this way. So here voltage is 0. So now when the voltage is given between the drain and source, at that time drain is connected to positive terminal of the battery and negative terminal to source. Now we know that in the N channel the majority charge carrier is electrons. So numbers of electrons here is attract here is the positive terminal of the battery or source of VDS. So flow of electrons is such like that, it's called natural current flow due to electrons, and the conventional current flow to positive to negative is called drain current, is called IT. So this way VGS is equal to 0. It means that when gate voltage is not given, at that time IT current can be increased. So VDS is increased, then current is also increased up to the majority charge carriers available in the channel. Now in case 2. Now in case 2 we are considering the voltage is negative. It means that VGS is equal to less than 0. It means gate terminal is negatively given. So upper portions of the gate is negative. So as we know, the capacitor having two terminal or two conducting plate between its insulation media. So if here is a negative terminal charge, so here is the positive terminal charge. So like that construction same here, these are the insulation is SiO2, upper side is the gate is the negative. So and the bottom of this is the N channel. So majority charge carrier in N channel is electrons, and P is the substrate. Here is the majority charge carrier is holes. Now due to that negative effect of the gate terminal voltage, the electrons in the n channel are repelled from this and holes are attracted this way. So in between this n channel, these holes and electrons are recombination processes start. So recombination processes start. At that time what happen? These free electrons, numbers of free electrons in n channel, which are the current flow through drain to source, will be reduced. So electrons repelled by negative potential of gate and holes are attracted to the negative potential of the gate. So these recombinations of that charge carriers is reduced, free electrons is reduced, so ID is decreased. So here as shown in graph, ID versus VDS. So here when VDS is given, so starting it will be increase sharply like ohmic region, and then after saturated and fixed, the constant current can flow at the time of VGS 0. Now if voltage VGS is decreased, it means negative, then gate voltage is negative, then ID will be decrease. If gate voltage is positive, then it will increase. So this way we can discuss about the n channel depletion type MOSFET. Now second one, same way, p channel depletion MOSFET. Difference is that here is substrate is n instead of p and channel is p instead of n. So sorry, we can also the supply voltage between drain and source will be reverse. Here is the negative and the positive. So what happen if here is the majority charge carrier is holes and these holes are attract this way, so holes current will be flow this way. So if we are considering the case this is a 0, VGS is equal to 0 at that time. Now in considering the voltage VGS is positive, so here is the positivity is increased, so upper side is the positivity is increased. Due to that p type material, p type channel is the majority charge carrier is holes and the n substrate is majority charge carrier is electrons. So same way happened when what in the n channel, same way happened in the p channel. The recombination process, holes and electrons are here, which reduce the free holes which are flow from drain to source will be reduced. So same way, if VGS is a 0, then current will be sharply increased and then it will be stop ID and then constant. So these are the value. If the voltage positively is increased, then drain current is decrease. So at that time when the start is the saturation mode, at that voltage is called as a pinch off voltage. So in these two case we see that the graph will be so that current will be flow due to the gate voltage and controlled by the gate voltage. So this way is the MOSFET will be working in a depletion mode. So next video we are discuss about the enhancement mode in N channel and P channel. Okay, thank you.